We present EventBox, a visual encoding of temporal and multivariate attributes in event sequences. We have integrated EventBox into Sequence C, a visual analytics system for the analysis of event sequences to support decision-making. We implemented user-driven transformations to enhance the interactive navigation features required to support EventBox analyses. The visual encoding of an EventBox uses as inspiration traditional scatter plots and box plots. The EventBox data representation and visual encoding allows the multivariate analysis of up to 5 attributes showing quartiles and outliers. Data points represent event occurrences. Their horizontal and vertical position are, in this case, their duration and start time. These are the primary attributes. Histograms enable the exploration of how primary attribute values are distributed. Secondary attributes can also be represented, transforming the histogram bars into stacked bar charts. In this example, we have doctor and treatment. The last attribute, breakdown, defines the color of the data points and will allow the split of an event box. Here, we use day of the week. For example, this event represents a patient visit with happening on a Tuesday at 10 a.m. with a duration of 60 minutes, seen by Dr. B for treatment 1. The breakdown attribute is used to split the event box and analyze their values individually. Here, this event box is divided into Monday, Tuesday, Wednesday, and Thursday. We show how the breakdown attribute is used to split an event box. In this case, we can compare how different attributes behave with respect to the day of the week. We can see that on Mondays, the average visit time is shorter. Tuesdays have longer duration outliers, and that on Thursdays, patients only undergo treatment 1. The data encoded in an event box can be the result of interactive transformations, such as substitution, aggregation, alignment, and sorting. We will now show an example of these transformations to enable the agile creation of event boxes. This example starts with 7 sequences and uses these transformations to study further event F. As an example of substitution and aggregation, we want to replace and group the events X and Y by the event A. Then we want to align the sequences by events C, F, and E. We start aligning by the hard alignment events, in this case C. Gaps are added as needed right before C to achieve its alignment. Then, we align by the second hard alignment event E. Similarly, more gaps are added. After aligning by the hard events, we now align by the soft event F. This alignment happens between hard events, and it also consists of adding gaps. The final step is to sort the sequences by event F. In the transformed sequences, we can see the F event aggregated, which can then be visualized in an event box. In this example, all the other aggregated events, C, D, E, and even the newly created event A could also be analyzed with EventBox. This example shows how using aggregation, an EventBox helps study 9,003 sequences representing the journey of patients leading to a visit to an emergency department. The EventBox is broken down into days of the week to analyze the difference in durations and the number of outliers depending on the day. We propose EventBox, a novel data representation and visual encoding of groups of events. EventBox allows users to explore individual events and sequential patterns alongside their temporal and multivariate attributes. We have integrated EventBox into Sequence C, a visual analytics system for the analysis of event sequences to support decision-making. We have extended Sequence C with interactive selection features and transformations to manipulate sequences and events that facilitate the creation of event boxes.